All right. So we are here at the 14th Nixpkgs architecture team meeting. Going over the protocol quickly. Let me do this here. I'm recording today, leading the meeting, and I think John can't make it. So I guess I'll also take some meeting notes today. Yes, so we have a bunch of things we can talk about. Alex isn't here today, but yeah, so one of the first things last week, just before the start of last week's meeting, Todd, who's also here now, talked a bit about spec. He's the lead of the spec team. Lovely to have you here. And you mentioned some things about the how spec gets external dependencies, how those get specified and resolved, and about you talked a bit about set solving and how that's kind of not ideal, and there's a better or a seemingly more efficient way with the was it the ASP answer set programming, and you wrote with some others, you wrote a paper on this, which I only wrote the abstract of, but it looks relevant to Nix as well. And so that looks interesting. I'm very interested in having the whole version declaration in Nixpkgs work better, and that certainly goes in that direction. But it also goes in another direction, which is that Nixpkgs currently doesn't have a good way to deeply override packages or to deeply change runtime dependencies of core libraries. Currently, you need to, in many cases, recompile the entire world from that. And Spec's model with external dependencies kind of is a way to fix that. So kind of two things that Nix currently struggles with that Spec has a solution for. And so let's see, let me go through the links here. I don't know, Todd, do you want to, do you have anything to say right now about this or anything to initiate?
Sure. Yeah, so I guess on the solvers, I wouldn't say that it's not a sat solver, because it gets converted to sat. I got into this and I started learning about different types of solvers, and it's actually a huge space for searching huge spaces. So answer set programming, it's basically you write your semantics in first order logic, and it gets converted to something that can be solved via sat and optimization. And so there's something very much like a sat solver underneath it, but it does optimization well. And I think the specification is way simpler, at least in my mind, for ASP than it would be for writing something to convert it to a sat encoding manually. So that's nice. Probably the other contender for something that you might use for a package solver is Z3. I don't know if folks have heard about that. It's an SMT solver, which is satisfiability modular theories. SMT is used a lot in program analysis, so like it can do things like infinite domains way better than ASP. It can also do combinatorial search. It's a little, in my opinion, it's a little harder to specify, and the I don't know, it's different from ASP. So those are things to consider. I know that Andreas Claude from the Debian project has started looking at Z3 to do fancier things in their solver. So he had a Mastodon post about that a while ago. But yeah, the ASP has been good for us, and I think it works really well for the kind of combinatorial search problems that you want to do in package managers. That's other comments. I think the external mechanism in Spec is probably not as pure as you all want. So essentially, you do specify your externals. You say things about them, like what version they're at, what build options they had, and basically things that would describe the installation. There's currently not. I mean, it's not like SPAC is tracking that thing as it evolves, and so people use this for things like OpenSSL on the system if they want to build against the system OpenSSL and have it upgraded automatically. The downside of that is that if you do happen to get an incompatible upgrade, it sort of happens invisibly to the installed software. So that's not ideal, right? You would like to have something that would let you track that provenance over time. And yeah, I think that's about it on the topics that you mentioned. Happy to answer questions.
Nice. I'm thinking for Nix that we want to maintain the purity of Nix, but at least the kind of version specification, the version specifications and resolutions are certainly very interesting for Nix and could be applied there even while still having purity. But yeah, that's awesome. I'd really like to look at take a closer look at the paper for next week and dig a bit more into the details.
Cool. I guess I have a question for you guys. So in Nix, does purity mean that you have all the provenance for something, or does it mean that it is as built from source? Like, what exactly is the official definition of purity for Nix folks?
So there's kind of a bit more nuanced. There's three kind of different kinds of purities in Nix. So Nix, that's on one hand, that's an evaluation language in which the build expressions and everything is written. This language can be pure, and that's enforced by the new Nix flags, but you can also have purity outside of flags. That just means that the input, the expression you give, so generally a Git repository, is the only input required to build the build expressions, the build recipes for Nix, the derivations. And so that you don't read from environment variables, you don't read from arbitrary paths in your file system to get to that. You don't fetch random paths from the internet and import those. So yeah, that's one level of purity. Once the Nix evaluator kind of finished, it produces derivations. And these then get passed to the Nix daemon, which builds those derivations. The derivations, these are build recipes, and the Nix daemon can run those. And there's another kind of purity there, and that's the Nix sandbox. All builds run in a Nix sandbox by default on Linux, at least. On Darwin, I'm not sure if it's enabled by default. But the sandbox prevents things like access to the internet, access to arbitrary store paths. Again, it does some other stuff here and there, like making sure the build uses the same build user, things like that. After the builder is built, it produces a store path. This store path also has some purities built into it, conventionally at least. Nothing prevents those from being impure. So the commands you run, so you build a hello package, you run the hello binary. This has some purities like it uses dynamic libraries from absolute store paths, hashed store paths. It doesn't use the dynamic interpreter for ELF binaries from some like /lib path. It uses also an absolute path there. But that's all kind of built into Nix packages. So nothing in Nix itself guarantees that. And you can also have impurities. It's to some degree normal to have impurities there because programs need to run and need to read user paths and stuff like that as well for data files and stuff. But yeah, it's really, I'm not sure if that explains the whole thing.
No, that is just a question. So it is kind of vaguely defined. It's not vaguely defined. It's just a lot of different things. Yeah. So I guess
So,
The thing that may be interesting to you about the paper is the main goal of that paper is really to reuse more pre-built binaries. So like with the solver, the problem that we kept having is that basically the inputs to the solver are coming purely from package files, and the spec packages get configuration hashes just like Nixpkgs do, because I mean it's based on Nix to some extent. And so if you had a minor tweak to to something where the defaults on a package in the repository changed, and the default resolution of something would get maybe different dependencies, but the installed dependencies are good enough. There's like no constraint that says you can't use them. Spac would still try to rebuild everything, because it was really only like it would get a configuration hash. It would say, hey, is this installed? And if it was, it would reuse it. If it wasn't, it wouldn't make any particular effort to use a different one. So the paper is really about reusing like either packages that are already installed by Spac, or externals. It'll try to prefer them, or packages in a binary cache. So like if you have a build that could perfectly well use a bunch of things from a binary cache, the solver will now include all of those in advance instead of just not thinking about them and only evaluating them by hash. And it'll try to optimize for essentially minimizing builds, or reusing as many of them as possible. You could look at it two ways. So that's where we are trying to improve Spac, because the biggest complaint people had about it, and I think it's similar to the one that you're talking about here, is that it just you tweak like one package and it rebuilds everything, and so people end up with like 6 versions of zlib, and they're like, why do I have this many versions of zlib? I don't need this.
yeah.
I guess the other thing that we're trying to do that's maybe interesting from the purity perspective is right, we don't do this now, but we at the moment Spac can only deploy things that are sort of as built from source, which means basically that you have the build and run dependencies that you built with, right? So if you built with one version of zlib, you cannot currently deploy against another one, because we require this like Merkle property for the hashes in the tree. And I think Nix does the same thing. We're trying to build a solver that would get us sort of the best of both worlds, where we could preserve all the provenance. We could say, hey, this thing was built this way, and I talked a little bit about this last time. But we would know that we're deployed against a different version of zlib, and we would have rules that say like, okay, these are where the compatibilities are. This is where ABI breaks happen in the package. And we could use semver semantics for that, or we could also, we're looking at introducing some things to say, this is the version where an ABI break was introduced, or things like that, to add to the language and make the solver understand that. It wouldn't lose reproducibility, because we'd have the provenance for both sides. We could rebuild the stuff that you've deployed against the way that it was built, and we could rebuild the other stuff the way that it was built, and then just deploy them. And what we do is we re-rpath them when we install. So we've got the mechanism for that implemented right now, but not the solver.
Yeah. Okay. Yeah, that's interesting. So yeah, Nix does struggle with a lot of these problems right now. I mean, the thing with reusing existing binaries, Nix currently does not, it always needs to do this whole pure evaluation from the start, and so it also can't know about the existing binaries, so it could reuse them. There's, however, on the, there's some things we can do there, like, right, if there's in particular, like options for package builds, which you can enable or disable, but also sometimes people don't care about whether it's enabled or disabled, and then there's some flexibility there to change, to pick a version that might be more likely to be cached. But again, in Nix, you can't really know about whether something is cached ahead of time, so you need to just kind of hope there a bit. And yeah, the thing with like deploying for another version than you're building, we just John Erickson and I think Alex Amin, they talked a bit about also an idea which could solve the same problem in Nix, where I think it was we build against just stub header files, or not header files, against stub library strings or something like that. And then only in the final step, when building a binary, we're actually linking against the concrete libraries. And this would then allow kind of changing the implementation of things, assuming they have the same symbols exposed. But yeah, the by using the solver, that also sounds like an option that could fix this. So
and the stub string sounds similar to something that we've thought about, which is, well, for something that's kind of core to spec, is that when you depend on something, you depend on a spec, which is like this. It's almost like a version specification, but you can also have requirements on like you want plus some option or some flags or things like that. And you can have an abstract or a concrete spec. So most of the requirements are abstract specs because they don't specify something that's buildable, something that has all the options specified. And so you can think of it as like it's a version of what you were talking about with the sort of stub name, but with some constraints on the requirements of the dependent. So essentially, like you can say, I need version 2 or higher, and I need this parallel option, and I need OpenMP support or something like that in the library. And then if we preserved those after build time for the thing that requires them, I think it would be useful because we could use those as constraints on what we allow to be swapped in when you deploy. So I think that's related to what you're saying. Because if you do that and you allow anything to be swapped in, you'll run into incompatibilities eventually.
Yeah. So you only give the requirement string with the abstract. Well, the abstract specs are what you specify, what users specify, and then this gets turned into a concrete specs with the concretizer. Is that right?
Yeah, that's right. And the abstract specs are like objects that you can manipulate in memory. You can like ask if one satisfies another, or if a concrete spec satisfies an abstract one. And so when you're scripting in spec, you can say, hey, does this thing fit in this box, right? And it's handy. We use that for things like target compatibility too. Like, does Haswell satisfy Skylake?
Yeah. That sounds pretty good. I'm pretty convinced at this point that Nix could benefit from. Kind of obvious. It can benefit from something like this. It's just, I think the main problem is just how to integrate this into Nix, because I think someone on Matrix mentioned they implemented a simple set solver for Nix, but Nix is like really bad for general purpose programming, and it's really slow. It misses many things that allows fast implementations. There's the option of implementing in C++. That would then go a bit against this team, because we are kind of trying to rely on just using the existing Nix implementation, not trying to go for changing that to make something work in Nixpkgs. So I don't quite see where we can make the next step there. Probably just, I think it would be best to just learn more about spec for now, how it does things, take a look at the paper.
Yeah, and you can get started with, the solver frameworks exist. I thought I was going to write my own solver in Python at first too, because of reasons like that. And ultimately we ended up just using Klingo and dealing with the bootstrap issues that brings on.
Yeah, I recorded Klingo in this discourse agenda. Hopefully it gets preserved and we can also take a look at it.
Z3 is also common. It's used by LLVM, so you may be able to find that out there more easily. But Klingo is pretty robust, so either of those could work. I would caution against writing your own solver, because it seems to be like that solvers are people's life work. I think writing a fast one that does all the things that you want in an ecosystem as complicated as Spac or Nix is actually a pretty darn hard challenge. So that's my only advice on that one.
Yeah, sounds good. MVP, you want to say something?
Yes, I wanted to mention that there is an alternative to having a set solver. Nixpkgs doesn't need a set solver because we bake in one solution. And the same way for updating the runtime dependencies when we have a newer version with fixes. There is no need for patching anything. And that was the security update branch that I had made a while ago and presented at an its conference previously. Probably badly presented. uh, I can provide more information. The simple idea is that we evaluate two NITs packages next to each other, but instead of evaluating two fixed points independently of one another, which will implies rebuilding everything, we implement one against the first one. So we have a base branch of NITs packages, and then we import everything we want to mutate. So if you want to migrate from one to another and just be replacing the references, you don't have to use a stub or a fake library having the same API. You can just use the previous version as your build reference that you already have.
So I did just take a look at the PR there. It's fairly old one, like 7 years old by now. It looks interesting, but I am having a really hard time understanding the concept there. I haven't taken a look at the implementation though. I'll try to understand it. To me, it's so currently the Nixpkgs model is fairly simple with just this one fixed point. And as far as I know, this PR would complicate this in a way where there's like two fixed points now in the stage between that, right?
Well, there is one fixed point to evaluate the base, which is what we currently build. And there is one on top, which is evaluating all the patches which have to be made on top. It's not that complicated. What is complicated is figuring out how it fits in Nixpkgs. If you are digging too much into the details of Nixpkgs, it does not apply as is on today's Nixpkgs because of all the back references that we have. But if we're going to simplify, such as using something like the simple override strategy, that's going to be easy or trivial to apply. The idea is that we only need a single fixed point and no other inner fixed point. So Haskell packages which are introducing their own are going to cause problems here, or Python packages and others. But the simple override strategies is here to remove this problem.
I see. So with the SOS proposal, this would like remove almost all of the complexity with the shipping security updates PR.
Exactly.
I see. That sounds pretty good. Yeah, Todd?
Okay, yeah, so I guess I'm curious what's if you do this, or how do I put my hand down? Oh well. So you said that you don't need a set solver, which is true if you ignore things like constraints on the packages, right? And so the reason that we have the set solver in SPAC is because the packages are basically written not with particular versions or configurations of dependencies in mind, but they have basically bounds, and they say like I can support version 2 or higher, and I require this option and things like that. And since those are preserved, we know what the constraints are to give to a solver, and then for the things that you're building in the reusing solve, where you've decided that you're gonna reuse some installed package or some external package, we know some constraints on the or we know some aspects of the external packages, right? We know that they are at particular versions. We know that they have particular options on them, and there's a way to express that. I guess the question would be, so if you have two fixed points and you try to merge them together, are you evaluating any requirements of the two packages when you put them together? Like, could that result in a very ABI incompatible result? And
So
that's sort of what we tried to solve in the paper with the solver, was we tried to preserve those constraints even when reusing things. And so I guess it's a matter of whether you want to check things like that when you integrate the software, whether you need a solver or not.
So we don't. The idea that I submitted was that that's packager responsibility to ensure that the API are compatible. We have no intent into trying to figure that automatically, or at least I had no intent when I submitted this ID. And
Yeah,
if there
and
is a
even
failure, then it's going to happen anyway. And that's, I will say, almost not our problem, as this is software which have to provide us the right fixes for each versions.
right. So
In
you've got a
terms of
stable thing.
solving the dependencies such as we have a limited set, I guess Nix today doesn't do that work at all. And we are doing it as we want to use the latest, and we might have multiple versions of it. And it doesn't, I'm not seeing that as a problem today. Or at least I'm not aware of it being a problem.
Yeah, okay. And I mean, even if you do use a solver, you are limited by the constraints that your packagers put in the packages and whether or not they're correct. So we do have that problem.
So one of the things is that the way it's designed is that you're building the same packages, but against different dependencies. So you don't have the problem of one package being updated to another and updating the dependencies. You're always building the latest in all cases. And if the package you're talking about is being mutated by having CVE applied to it, then you're building both in the sense that you're building one against the known base that you have, and you're building one against the patch versions that you're fixing by replacing the dependencies.
Yeah, one of the things that we are trying to represent right now is which dependencies affect the ABI of the root of a DAG. So like if you have a package that depends on boost, for example, and it exposes boost types in its headers, then your package has both its own ABI and it also relies on the ABI of boost. And so even if you rebuild all the dependencies there, if consumers of that header ended up using those types, you could still have an ABI incompatibility between those two things. So we're trying to figure out ways to represent that, and we don't have a solution for that right now. But it sounds like this is more like for things with a stable C interface and without, with where all the dependencies are hidden behind something in the header.
So with Nixpkgs, it just has like this position in the Nix world where it's the authoritative source for packages, and it runs one CI building all of those packages. MVP, you need to go now. CI. So this is good because you can always like have the latest version of packages and kind of ensure it works with that. And if you have enough testing set up and enough people maintaining that, then it kind of works. But you are kind of limited to always the latest version, and so Nixpkgs is limited in that way. And now with kind of Flakes coming up and introducing like the idea that people want to have other repositories beside Nixpkgs with their own packages, and then you come up with like, oh, but now you have requirements and dependencies on other people's Nix expressions, and those then need to have some APIs to work together. And so I feel like this problem is really going to come up much more now, and it has come up already. Honestly, that's one of the main problems with Nix Flakes, in my opinion, where there's just no way to kind of handle requirements and dependencies between packages and derivations.
Yeah, it seems very similar. I mean, we have separate repositories too, and we have like upstream SPACs. You can point a SPAC at another SPAC and use the installations from that one. And we run into things like this across those. So these are all the places where we wanted to reuse more, which was a lot of the motivation for the solver work.
Yeah. Quickly going to take some notes on that.
I think like we have this notion of environments where you have like a single YAML file that sort of encapsulates a set of things that you want to build. And we're trying to make those so that you can include other ones, which seems kind of a lot like Flakes, to be honest. I don't think we have. I looked at Flakes and it seems like there's a fairly nice, or at least pretty good user interface around it for, you know, including some other, I don't know, Flake, whatever Flake is, right? We don't currently have the pieces bundled up in one unit that way. There's probably more sort of separation of the moving parts than you want at the moment.
What is the component called again? You mentioned that's kind of similar to, in some ways, to Flakes.
Environments. I mean, so we
environments.
You write a spec.yaml, you can throw it in a repo. There's a spec.log file that comes out with the concrete version of it. And you could include a spec.yaml or like a URL for another environment into an environment, and it'll pull in like the configuration. It doesn't yet pull in things like installations or like package build descriptions yet from a lock file from another environment, which I think is what we want to do to be more like Flakes. But it does, those two things seem pretty similar too. Our motivation was really that like there are people who want to build on HPC machines, and it can take a lot of configuration to get essentially all the things set right to port to that machine. So we wanted sites to be able to put an environment in a repository somewhere and say, like, here's the starting configuration for like Summit at Oak Ridge or, you know, one of these big machines. And we wanted people to be able to just include that and then start building with the settings that the site provided. So that was the motivation on our end.
All right, cool. I'll also take a look at that, at the section in the docs. Then sounds cool. So I do think so we aren't a lot of people here, maybe not the right people to discuss the following points of the meeting. But so we have, well, I guess at least
I also have to leave.
Right, yeah. So I guess that's
you're right.
Yeah, probably a good point to end the meeting. We didn't get to all the points today, but yeah, I guess many people will be at Nixcon, maybe traveling as well. So we all have time to discuss a bit there. All right, so yeah, thanks for being here, and see you next week or Nixcon.
Yeah, thanks, and thanks, Todd, for the interesting info.
Yeah, sure. Yeah. It's really cool to talk to another packaging community about the design decisions, because I think it's super helpful to compare.
Yeah, same. All right.